That is the MRS of the individual. Which should look like this. That's the MRS, we need it later. That's equal to rated price. So we're going to solve for Y. That is what we get, right? Okay. And then we're going to use the bullet line. You plug this there and solve it. How many we have there? This will cancel out. We have 4, right? Is that 4? It looks like 4. So demand for X would be I for X. What's the demand for Y? Using the shortcut. What's the demand for Y? I P Y. What's the multiple? 3. Or again, that's just for Cobb-Douglas, where you can shortcut almost everything. So what is the initial bundle? That is when the price is 1, 1. What's the initial bundle when the price is 1, 1? The income is how much? 200. That's 200 divided by 4, that is 50. 50. What about Y? What's the demand for Y? 1? 50, right? Yes, 600 divided by 4. B is a terminal bundle, that is when the price becomes 2. What's the demand when the price becomes 2? Anyone? 20? 5. Right, that's the demand for X. For Y, it will be the same. So we call A to B total effect of the price change, which is minus 25 units. The individual consumes 25 units, because the price goes up by $1. Graphically, if you recall, we found point C that isolated for substitution effect. Then we said the leftover must be our income effect. So graphically, we found C. We need to find C. If we find C, then A to C becomes substitution effect. C to B becomes income effect. Alright? Okay, let me graph it. See if we can find a way of finding C. That's the initial bottom line. That is the terminal bottom line. The consumer consumed 50. Then 25. This was A. This was B. That was the total effect. You want to take that total effect and spread it into income substitution. Alright, so if you recall, we graphed the original indifference curve. That's what we do here. We graph the original indifference curve. Don't graph it too tight. I've seen people graphing it this way. If you graph it too tight, it's very hard to find anything, right? Very hard to find point C. At least short in the graph. So that's the original bottom line, that's the terminal one. In this one is the impact of price change, income change. The price went up, he has less money. So what should we do? We should give him money, compensate for lost purchasing power. We should take the no budget line, in this case shift it up. That is a elimination of income effect, lost purchasing power. Make sense? All the way to contingency. That is point C. So we give the individual money, now he is as happy as before. Point C will eliminate all income effects. Alright, that's what the graph says. Now we have to numerically find C. By looking at C, what do you see? That's so poetic. By looking at C, what do you see? Anyway, what do you see? It's the same thing. I can't say it anymore. Where is point C? Point C is on the same indifference curve that point A was. Alright, so we can use that. Characteristic number one. We don't have C. We don't know where it is yet. But it must yield satisfaction equal to A. Alright, so we go to the utility function. That's the utility function. That's the utility of C that we don't have yet, but it must be equal to the utility of A, and we have A. That is the utility of C, which we don't have it yet. Equal to the utility of A. Make sense? That is the first characteristic I can use. To simplify it, get rid of this 20. Give me this one. How much is that one? I want that number. How much is that? What is that number? I need it. I'm going to use it in a bit. How much is it? 4,000? 12,000?
990.38.
9?
90?
90?
Yeah, 0.38.
Just round it, it's fine. 90. That's okay. That's one. I need more. One characteristic, two unknown. That's not enough. I need one more. What else you see? Look at point C. What else do you see there? It's on the same indifference scale. We already used that one. What else you see? We found it by tangency. So the MRS at point C is equal to the slope of the no bottom line. That's the way we got it. That's the way we got it, right? So MRS, which is this one, at point C must be equal to how much? The no bottom line, not the old one. What's the no bottom line? 2 divided by 1. If you put 1, 1, you're going to get point A. If you put 1 on, it puts you to original point. It's tangent to the no bottom line, not the old one. Alright? So if you put this one, you're going to get A. If you put this one, you're going to get C. So I've seen people putting the initial the price and getting A and then saying the total effect is 0. Sorry, the substitution effect is 0. It's a mistake. Put the new one, which is 2 divided by 1. Then use the second one to find Y. And take this one and plug it there, and you will be alright. So let's write it. That. Then write it this way. Right? And then get rid of this one by solving it. Right? Again, if you solve it differently, solve it differently. But plug y in the first equation, find x. What do you get there? That is point C. That will isolate for substitution effect. What do you get? By the way, since all the functions we use are for normal goods, C will always be between A and B. Right? C is always between A and B. So if you have 50 and 25, you get somewhere in the middle. You don't get it outside because the good is normal. Right? What do you get? It should be somewhere between 50 and 25. A and B. What do you get? 29 point? That sounds right. So this should be 29.7 minus 50, which is minus 20.3. This should be 25 minus 29.7, which is minus 4.7. And they obviously adds up to minus 25, which is our total effect. Just a note, since we work with normal goods, the sign of all effects are the same. If the price goes down, they're all positive. That's the next question. If the price goes up, like this one, everything is negative. So you can eliminate the sign, work with absolute values. Make sense? That's fine. In the real world, it does matter because sometimes you get inferior goods where the sign matter there. But the function we use are all normal goods, so the sign is always the same. It's either everything negative like this, or everything is positive like this. Like the next one. Make sense? Okay. So this individual, he reduced consumption, mostly because of substitution effect. I recall when I was studying demand, until I went through this one, it just didn't look right. That's the crux of it, right? People consume differently because of these two forces, right? Last year we had that carbon tax. Remember that? What did carbon tax do? Increase the prices. Make sense? When the price goes up, what will happen? You're worse off. Make sense? Because you have less purchasing power. What did the government do? They send checks. That was an attempt to eliminate income tax. The idea was we will care about substitution. We want to rationalize your consumption. We want you to consume less, but we don't want you to be worse off. So they send checks. Right? If the checks are good enough, you're not worse off, but you consume less. That was the goal. But obviously in the real world, people consume differently. If the checks are all the same, the outcome won't be optimal. If you consume a lot of gasoline, the checks will be too small. You won't be happy. If you don't consume at all, well, you got a check for nothing, right? You'll be more than happy. Make sense? So very hard to apply it in the real world. But most often when the government comes with a policy of rationalizing consumption, they send checks because the idea here is we don't care about income effect. We don't want to make you worse off. We care about substitution effect. If you're consuming too much, we raise the price to force you to consume less. But we don't want to make you worse off. We send checks, compensate for lost purchase power. Make sense? So has applications. It's not just a theory. Next one is sort of the same, but I went to the other side. Here the price goes down. So besides changing the function, I change the direction of the price change as well. So I'll let you do both sides. And that should be good enough to solve any question. Okay? Okay. Let's see. I need the MRS. What's the MRS here? Anyone? What's the MRS? 175? 1.5. Why? X. That should be y2x. That's your MRS, as you know by now, you need that one. This is the MRS. So we need it later. That should be equal to the price. I can use that one to find the demand. That's equation number 1 solved. Equation number 2 are budget line. Right? I take this one there. End up with this. And that will be eliminated. How many I have there? That's 1, that's 2, that's 3. Right? So actually, how much? I, 3, x. What about y? What's the demand for y? I, what's the multiple? What's the multiple? 2, 3. Again, if you don't like this, just plug it in. It will give you the same thing. Right? So I found demand for x and y. That allows me to find the initial bundle. And for that, I'm going to plug the income, that's 60. The initial prices. That is 2. So what's the initial bundle? What's the demand for x? That is how much? 10. What's the demand for y? 40. Right. That's 260. That's 31. That's 40. What is a terminal bundle? I try to avoid call it bundle B because it sounds like bumblebee. Someone told me, right? So I try to avoid it. Bundle, well, terminal bundle, right? What's the terminal bundle? The price of X drops from 2 to 1. That's 60. That's 3. That's 20. That's 20. And Y remains the same. Right? So the total effect of price change is A to B, which is if I find the point that I isolate for a substitution effect and call it C, then A to C will be our substitution effect, then C to B will be our income effect. So I need to find point C, which isolates for substitution effect. Let's see what the graph says. That's the initial bottom line. That's the terminal bottom line. Right? And the consumption happened there. Initially 10, 10, 20. That was A. That was B. That is total effect. Right? Make sense? That's a total effect which we need to decompose. Okay? Okay. What's the next step? Graph the indifference curve on point A. We don't need B. If you graph B, it will be just too many lines there, right? It just doesn't do anything. Right? Graph the indifference curve on A. If you graph B, you're wasting time. And don't graph it too tight. Don't graph it like this. Then it's very hard to show on C. Alright, graph a bit flat. So now the price went down, you move it from here to here. You need to eliminate the income factor. Take away money from him because the lower price gave him more purchase power. Shift this one backward. Right? All the way to tangent C. Make sure you have a ruler, make a tangent. That's a tangent. See, that's awkward graphing. If you have a ruler, I can't even erase it. If you have a ruler, that looks okay. If you have a ruler, let's shift this back, get the tangent C. C, since the good is normal, is always between A and B. We don't have a numerical question which is not. It's just a graph where the good is inferior, stuff like that. For mathematical function we use, it's always normal. So C is always between A and B. Right? That is point C. So based on the graph, what is the name of this one? Based on the graph, what is the name of that one? That is R? Substitution effect. And this is R? Income. Right? Makes sense? When the price goes down, everything is positive. When the price goes up, everything is negative. That's sort of normal good. Okay? So we need to find point C. What are characteristics of point C? Number one, is on the same indifference scale that point A was. So utility of C is utility of A. They are on the same indifference scale. That is C that I don't have. A, I have it. And they should yield the same satisfaction. That is utility of A, and how much is it? How much is utility of A? How much is utility of A? How much? 1,422? Just round it. 23. Rounding test-wise doesn't matter. Unless the question says it, it really doesn't matter. There might be in one case later where rounding matters, but for anything else, it really does not matter. So don't worry about it test-wise. What's the condition number 2? At point C, we have tangency to the new bottom line. Not the old one, the new one. So MRS of point C, and MRS is this one. Should be equal to how much? How much should be MRS at point C? Don't use the old one. You're going to get point A. A lot of people do it, right? They're going to get point A, then A and C are the same, right? Use the terminal budget line, 1, 1. This one. These two are parallel, not this one. So you're going to use 1, 1. And you're going to get Y from it. And then you take this one and plug it there. XC 0.75, 2XC 1.5, that's 14. If you solve it, that would be XC 2.25 equal to 1423 divided by 2, 1.5. I'm going to eliminate this one by reversing the power. Again, if you solve it differently, just solve it the way you solve it, right? That's the way I do it. If you actually have a different way of solving for equations, just do it the way you do it. Make sense? Okay. People learn stuff differently. That's the way I would have done it. I would have said, this is the power of 1.25. It goes down there. The power will add up. That's 2.25. If I want to eliminate that power, I reverse it. That's the way I do it, right? But if you do it differently, that's fine. How much do you get there? You must get something between 10 and 20 A and B. 15.8, not 16. Round to 15.8 or 9? 8. 8? Round 1 digits. If you round the whole thing, say it's 15.6, you have 16, that's probably too much. Round 1 digits, right? When I say we don't care, the number like in thousands, it really doesn't matter. But if it's in tens, that's sort of, you probably should round 1 digits. Use your common sense. Oh, we don't care, but don't round when this is 1 digit. 8.5 is not like 9, right? But 8500.1 is 8500, right? Anyway, okay, 15.8, and we're done. That is 15.8 minus 10, which is 5.8. This is 20 minus 4, 15.8, which is 4.2. So for this individual, the two effects were more or less the same. The reason he consumed more is more or less both equal. For the other guy was mostly substitution effect. For this guy, it's sort of more or less the same. Make sense? Okay. That is this. Just a note. On your quiz, I gave you A and B. So you don't need the demand. The demand here I put it because we want A and B. If you have A and B, you're supposed to solve for the rest. You just need MRS. That's the only thing you need, right? So for that question, you just need MRS to get the second condition to find C. Right? You don't really need the demand. That's simplification of what you see there. Make sense? Okay. Make sure when you graph it, which the question asks you to do it. Make sure when you graph it, you shift the new body line towards the old and the difference curve. Right? Don't shift the old body line. That doesn't mean anything, right? I don't know what you're doing if you do it. Shift the new body line. See, I'm stuck. I'm stuck. Yeah. Shift the new one, not the old one. Alright, shift the new one. Let me see which one I gave you. I gave you the price going up. I gave you the price going up. Sorry, just going up. I gave you the price going up. That's similar to the prior question, not this one. Alright, so similar to this one. You should take the nobody line. How to shift it, you get a tendency that I identified on C. Right? Okay, that is this. Don't use AI for the quiz. The TA showed me like couple, but they were AI generated. Now they have to figure it out. It's very easy, right? The AI does not use it the same terminology, does not use it the same way. It's obvious. Don't use it. Number one. You're gonna get no marks on it. Number two. Don't leave questions blank. If you don't know them, you have now to try them.